As we begin a study of instrumentation and measurements, we will start by looking at measurement systems and how they are broken out into components. And so this is a common figure that you'll see over the next few weeks, where the measurement system takes a physical variable and it measures it, translates that measurement in some way. It gets acquired at another location, and then it is processed in some way. And so when we think about the sensors and the transducers, what we're looking at is how we measure the variable that you're trying to measure. So temperature, humidity, pressure, how is that changing a sensor? And how can that sensor create some sort of signal or physical output that will allow that measured variable to be something that we, the user, or a computer, can understand. And so what is it that changes with the variable? How can we measure that? So if you think about temperature, temperature changes volume of a fluid or volume of a gas. Temperature can change the resistance in a wire. And so how do we use that to capture a measured value? And so the next piece of this would be your signal conditioning. How does a signal get from the instrument that experienced the variable to somewhere that it's useful? If we're talking about a physical, mechanical sensor, such as a glass bulb thermometer, the volume of the fluid in that glass bulb is changing with temperature, and then the signal is acquired through a scaling that happens on the glass. If it's resistance that's changing with temperature, now I need to set up a circuit that can measure the changing resistance as the temperature changes. There's additional thoughts about what if the signal is too small or too large? What if there's noise impacting the signal? And so all of that gets considered here in this signal conditioning step of the system. DAC hardware is the terminology for anything that acquires the data. And so you'll see the DAQ come out of data acquisition. And data might be displayed directly on a mechanical sensor. It might be analog data that's being captured at an electrical component where it's able to measure voltage or resistance. And if it's analog, before it gets to a computer, it needs to be digital. And so we have all sorts of considerations at the DAC hardware step. And for, it ranges in the tens of dollars for things like Arduino that can work as DAC hardware to the thousands of dollars, which is some of the higher end industry types of hardware that NI produces. And that's what would be in the lab in the CETA building. And the Arduino is more of a benchtop first run measurement hardware. And so that allows you to more accessibly measure data on a system that doesn't cost thousands to set up. And then as we get to the processing step is usually considered a computer. It could be humans taking data in a more manual way, but we're certainly going to switch very quickly into an efficient way of managing data, which is computer systems. We might store the data, we might analyze it, we might then take data and inform a control system. If you think about a thermostat, the temperature that is returned from the measurement cycle, or the measurement system within the thermostat, informs the HVAC system whether or not the heating or cooling needs to be active in that location. There's also a possibility that the end user, a person, might do processing and control systems work. We might change our decisions based on the measurements that we're seeing out of the system. That's certainly true on an analog pressure measurement for my tire pressure. If I'm not using a digital air pump that measures the pressure dynamically as it provides air to the tire, I need to be measuring the pressure in my tire and deciding myself when I need to stop filling the tire based on what the tire pressure is at. And so there's all sorts of ways that this involves humans. It could be completely computerized. It could be very manual. And all of this speaks to the variety of measurement systems, that ultimately break down into these pieces where you have a measured variable that goes through a sensor and or transducer. It is generating some sort of signal, mechanical or electrical. It's being acquired somewhere, and then it's used in some way. And so in our first meeting, we'll be using some small group discussion time to investigate some everyday measurement systems. We use measurements all the time. Most of us have control systems in many of the different pieces of equipment that we interact with on the daily, and we often are making decisions based on measurement output. So that's what we'll be discussing as we kick off this semester.